So this is a video tutorial that I'm preparing for a very simple problem shown on the screen. Basically, we have two blocks that are going to be sitting on this track, and they think about it as racing against each other. So it's going to be a mechanism that's going to be creating the digital mockup, and the velocity profile for these two blocks are defined in the next slide. By the way, the total length of this thing, I assume, is 21 inches, and the two blocks, which are referred to as the blue block and green block, we're assuming that overall the simulation is taken over 10 seconds, so we model this in for a 10-second period, and for example, they both start at rest, and if you look at the green one, after 2 seconds, the green block is 5 inches away from where it started, and then it sits there for another 3 seconds, and then again it takes off at a constant velocity of 3 inches per second. So this is a configuration for the green one, and the blue one is again over 10-second period. The first 3 seconds it sits idle there, then it moves at 2.5 inches per second, so uniform velocity. So basically in 2 seconds it goes by 5 inches, and then it sits there for 4 seconds, and then build up the speed and moves to the final location with a speed of 15 inches per second. So over 10-second period, they both start at the same location and they end at the same location. Now, these rules, these are we refer to them as rules, are going to be done based on sketches. So I'm going to do two tutorials. One is a video clip based on sketch rules, okay, and that's the first one I'm going to do, and then we'll come back and do based on rules which are coming from formulas. Now, notice that here, although this is the true velocity profile and position profile, one can create non-dimensionalize it, normalize them. So I can also input exactly the same motion in the form of, for example, the time non-dimensional going between 0 and 1, whatever the unit is. There is no unit here. And then the location goes between 0 and 1. So later on, of course, I have to scale the displacement, as you will see, by a factor of 20, and this is proportional to 10-second period. So we don't have to worry about the scaling of the horizontal axis, but we do have to specify the scale by which the simulation is going to be done later on. So either we can input this as two separate sketches, or that as two separate sketches. And location of the sketches are totally irrelevant. You can do it any way you want, so I'll just be very oblivious towards that. Okay, good. So let's go ahead. The first thing I'm going to do is create the assembly constraints. So let's anchor the track first. Anchor the track right there, and then point between this edge and that edge. Okay, and coincidence. For example, this plane and that plane. Okay, and update. Okay, let's also move this thing all the way to the back, all the way to the end. So I will make a coincidence in this vertical edge and that vertical edge, and update. The only reason that I created this constraint was to move this thing back. We don't need it, so I'm going to deactivate it instead of deleting it. Good. Did I do that? Yeah, I think I deactivated it. Now, let's do the same thing with the other one. So coincidence between this edge and that edge, and coincidence between this plane and that plane, and update, and finally move this thing back. So coincidence between this vertical edge and that vertical edge, and update. and deactivate this particular constraint, or delete it, whichever you prefer. Okay, good. So now these are the these constraints, these assembly constraints, when we go to digital mockup, are automatically created, automatically turned into prismatic joint if we ask it. So here is the start, digital mockup, DMU kinematics. Get the magic wand out because we're going to convert these automatically. New mechanism, okay. Auto create, and all right. So let's see what kind of joints we got here. We have two prismatic joints. Each one of them has a single degree of freedom. That's the overall system degree of freedom is 2. Now, I will have to insert 2 parts in here, and these parts are sketch 1 and sketch 2, or a single part with the 2 sketches in it. It really doesn't matter. So let me actually do the following. Why don't I go back to assembly design, which is, let me go back to the assembly design right there, okay, and insert 2 parts in it. So insert, insert a single part with 2 sketches. So insert, insert new parts, new part in there, and I'll say this is the dummy part for 2 sketches. For 2 sketches. Okay. Say no. Okay, there we are. All right, so let's create our 2 sketches. So, for example, on this, it's totally irrelevant. I'll make it on the XZ plane so it doesn't, or XY plane so it doesn't clutter this mechanism. On the XY plane, I will, let's go into the part design. We are in part design. In that part, on the XY plane, I will sketch. All right. So let me sketch basically this curve. Okay, the green one, for example. All right. So the first one is for the. Let me say the first one is for the blue one. Okay. So I'll put this thing in there. Now let's see. Where is there's the coordinate system. Okay. So all right, let's make a profile for the blue one. For the blue one, this is going to be eventually I'll put these with the right scale. So here is this, and there we are, and finally there. Okay, so I want to show you that what I drew here is actually this bottom plot. Now I have to put some dimension here so that it matches that particular drawing. So let's see now, where is the dimensions? Right there. Okay, so the length of this thing, what is this? The length of that thing is 0.3. Okay, so 0.3. Okay, don't let it bother you, because if you look at it, you see that it's right there. And then this point is at 0.5 with a height of 0.25. Okay, so let's go here. So dimension between this point and this axis, this is going to be 0.5, and this height is 0.25. Just look right here, 0.25. Okay. This was 0.3. I'm not sure whether I had 0.3 or not. So did it say 0.3 here? Yeah, I think no, that's 0.3. Okay, so 0.25. So here to there, this is 0.25. Okay, good. And now this point over here is, let's see, is 0.9. Okay, so 0.9, so dimension between this and that is 0.9, 0.9, and finally this height is 1. Okay, so from here to there, that should be 1. All right, let's fit this thing. There we are. In fact, let me hide this and hide the block and hide this block. So this drawing that you see here, just notice something, there's a mistake there. From here, I also need the dimension from, let me see. The dimension from here to there should be 1. Okay, the dimension from here to there, it should be 1. Okay, so what I have done here, this graph that you see here, is supposed to be this blue one. Okay. All right, let's go back there. Just so that there's no misunderstanding, I'm going to exit this, and I'm going to call the sketch. Where was that sketch? Right here, that's the first sketch. I'm going to call it the blue one. So properties, I'm going to change the name of it to blue one that we can easily identify. Red sketch, blue sketch, blue sketch. Okay, good. And all right. Then on the same plane, on the XY plane, I will draw another one, draw another sketch. If this is bothering us, we can actually hide this. The blue one I can hide. And I go and create this green sketch as it is shown there. So let me try. So a profile which looks, where's the profile? Right there, starting from 0, goes like this, and it goes like that, and it goes like this, okay? And then I dimension it accordingly. So let's see now. The distance from this point to that point, according to my drawing here, is 0.25, and that happens at x of 0.2. So this is 0.25, and the x location, in other words, from there to there, it is 0.2. Good. And then we have, let's see now, from this is at non-dimensional time of 0.5, and the height is 0.25. Okay. So this is going to be from here, from here, this to that axis, that is 0.5, and of course the height is correct. All right, and then this is at time of 1, non-dimensional time of 1. Okay, and the height is the non-dimensional value, which is also, if I'm not mistaken, 1. Let's check that. This height is 1. Okay, very good. We're pretty much done there, so we exit. This is the other sketch, and let me change the name of this thing to the green one. So properties, and this is going to be green sketch. Green sketch. All right. These are totally unnecessary for display purposes, but I can choose it when I need. So I'm going to hide it. Let's now bring those parts that we hid in the front. So hide and show, hide and show, and hide and show. Here are my sketches that I don't need. I just leave it there. Okay. All right. So let's go to the DMU right there. Okay. Let's make this thing angle driven. Length driven. This is length driven, and we make it from 0 to length of 20 inches. And let's make this thing also length driven, 0 to 20 inches. Mechanism can be simulated. Okay, you can actually see that. Let me see if I go to DMU, which is right there. Okay, so this is simulation with command. You can see that there are two sliding bars here. One is controlling the blue one, the other one is controlling the green one. Okay, so we close it. We now want to simulate with laws. Okay, so this was basically manually moving these things. So go to the icon which says simulation with laws. All right, now notice that here it says that you have to specify the laws. So we say, fine, let me close this thing. And this time, what I'm going to do is I'm going to, let me see, double click on the command, command 1. It says link it. So I'm going to link, this is for the blue one, as you can see. So I'm going to link this thing with the blue sketch. There's the blue sketch up here. And the maximum time value is 10. Okay, that's fine. That's fine. Okay. Good. All right. And let me just check something for the scale. Let me see what the scale is. So that's okay. Now we say okay, and let me do the same thing with this other command. So link it to the green one. Time value 10. That's fine. All right. The only thing that I have to do is to specify those scales. So the scales, let's see how we do the scales. Let me double click on this law. Yeah, double click on this law. Here is where you specify the scale. Okay, the scale in the Y direction should be 20 because I reduced all the positions by a factor of 20 in the Y direction. So this is going to be 20. And for the law number 2, double click on the law 2 in the tree. You make this thing 2. 20. Sorry, 20. If I had used the actual position, then I would not have to change the scale. The scale would be actually whatever I have. Okay, good. Would have been 1. Okay, so let's do it. So simulation with laws. By the way, just to make sure that we have done this thing correctly, let us plot the velocity or the position of these corner points. Okay, so let's do that. So let's create some sensors. First of all, we're going to move to DMU. Let's create 2 sensors. So let's see now, where's the sensor? The ball rolling down a hill right there. Okay, the first one is going to be, let's actually call this thing for the blue block. Blue block. Reference product is the track, and for the point, let us select this this point. Okay, and then we say okay. Let's also do the second sensor for the green block, because sensors are for individual points. So this is going to be green block. green block, and reference product is the track, and the point is say that corner point. All right, now we do simulation with laws over a 10-second period. Activate our sensors. So let's see now. We're looking at position along Y for sensor 1 and sensor 2. So let's see now. Let me see. This is the blue block Y position, and let's also plot the velocity. Y linear speed, and same thing with the second sensor, the green one, Y position, and Y linear, linear, not acceleration, linear speed. Right there. Good. So move this thing out of the way. Run the simulation. Okay, you saw that actually they paused and then they moved on. So now let us look at the graph, and these are exactly what we had before. For example, if you look at there's something I think I forgot to plot the position of the blue block. I did the speed of it. So okay, let's do it again. All right. So rewind. And clear the history. Don't forget to do that. So what is it that I forgot to do for the blue block? I did the position and the velocity. That's good. I think for the green block I forgot to do the position. For the green block, yeah, right here. See that? The Y position. Okay, good. So now I'm going to run it again, but at the same time I'm going to make this thing a little bit bigger so that these things get to the end visually at a slower speed. So make it 200. Okay, it takes more steps, that's all. So play it. It's going to stop. The other one is going to move. Yeah, see, this is following that location path that I gave it with sketches. They reach at the same time, end at the same time. So now we can look at the graph. Okay, so if you look at the first one, this is the blue block, and the blue block, the position of it. The position of it is which one is this? One of these is not right. So let me see. Let me check my graph here. So for the blue one, I may have inputted the values incorrectly, but let's see now. The yellow one is correct. The position, you see that what the yellow one means, the blue block. Blue block is correct. Why do I have both of these? Oh, I'm sorry. This says IRC. It should have been vertex. Okay, blue vertex and green vertex. I somehow. Okay, let's go and clean this up one more time. I screw up in selecting these things. So rewind, clear the history. Let's carefully do this thing. So for the blue block, there's the blue block vertex. That's fine. Yes. And linear speed. Yes, that's correct. Okay. Now let's scroll down. Select the green one. Green one, that's not what I wanted. I wanted the vertex position. That's why these things didn't look right. Okay. Good. Let's play it. All right. And now I suggest that you compare these with things that we had in the PowerPoint slide. So here's the blue one, the yellow curve. See that? Stops, and then it moves, and then it stops, and then it moves. And here is the position of the vertex. Moves, stops, moves. And these other ones are the velocities, which agree with what we've got. That takes care of the video tutorial for doing this problem as a sketch-based law.